Welcome, everyone. Thanks for joining us today on the Cornell Veterinary Podcast, where we deep dive into the discovery, care, and learning that happens at Cornell University's College of Veterinary Medicine. I'm Dr. Michelle Moyle, visiting assistant clinical professor and lover of sports. By the way, everyone watches women's sports, and if you're not watching them, you should be asking yourself why, because the WNBA is going off right now. Just as an aside, in this episode, I am so extremely excited because we are talking to Dr. Glenn E. Simmons Jr., and he is an assistant professor in the Department of Biomedical Sciences. I have to read. There's a lot of good stuff here, so I'm going to look down so I can read all of this amazing description. Dr. Simmons is a molecular biologist and health disparities researcher, and we will talk about that because I'm very excited to talk to you about that. His laboratory is investigating the role that fats play in initiation and maintenance of tumors. It's incredible. He also works to increase the engagement of African American men in the area of prostate health. Dr. Simmons received his BA from the University of South Florida and trained at the Moffitt Cancer Center as an NCI undergraduate research fellow. He obtained his doctorate degree from Meharry Medical College. Welcome to the show, Dr. Simmons.
Thanks for having me.
Yes. Can I ask, what is an NCI undergraduate research fellow? Because there are a lot of letters in science.
Yeah, a lot of letters, alphabet soup, right? So there
Seriously.
was a program at Moffitt that basically sponsored undergraduate students to do research projects or programs for an extended period of time. So unlike kind of the summer REU, this was kind of how I got my grocery money as a student. It's a really long story about how I got into it, but I was lucky enough to have mentors that were like, hey, you sound like you like science, go do this thing. And it turned out to be 4 years of research year-round at Moffitt.
So for some people, research is like a passion and a love. For people like me who run in the other direction, this is amazing, an amazing opportunity. And we're going to get to mentorship in like a few minutes, kind of further on in, because I'm really excited that you said that. That's just so important. I'm going to get to like the like nitty gritty that I know a lot of Cornell listeners want to hear about. What made you want to be a scientist? Like you were like one day like, yes, this is the day I will do science.
Right. Honestly, like I can't remember a time. At one point I thought I wanted to be an artist, and like a lot of young boys, I thought I was going to be an athlete. And physics basically changed the trajectory as far as sports were concerned. But when it came to doing science, I think there was just always something just so cool about not just discovery, but creation. I thought I was going to be an engineer. I watched, a lot of anime as a kid. It's like, ooh, like, look, they're making robots and the robots are flying all in outer space. And so that was kind of my gateway into science. And then I started learning about biology and realizing like, hey, we can actually manipulate biology as well. And once I realized that someone would pay me to do it, that was it. It was like, I don't want to do anything else. Like, I just have to figure out how to make a living doing this. That's all. So, yeah.
Yeah, get paid for your passion. That's awesome. And a shout out to anime lovers everywhere. Like, great. So I love that. That is a gateway. And I think yours is a story that's really neat. Like sometimes we don't recognize that like maybe we like something consistently but we're like focused on doing other things. And so I'm sorry about your athletic dreams not working out, but I feel like it worked out for Cornell. And so what are you focusing on right now? Actually, you know what? Just kidding. I went because I creep on my guests, and I went to your lab website. And before we get to what you are focusing on as a researcher, I really wanted to focus on this because the first sentence I saw on your lab website, which I really loved, and I would just love you to briefly explain, is determination is our superpower. I love it. Can you just explain, like, why is that up there?
I think it kind of comes from a bunch of different places, but I feel like it encapsulates not just the motivation, but really the spirit, that I take into my endeavors in life. And everyone I bring into the lab, I try to make sure that they kind of have a little bit of that, moxie, to them, where it's not about necessarily having the skill already. It's not about having the pedigree, but it's about knowing, like, I really want to make this thing happen, whatever that is, and allowing that to drive everything else. And so I I got a very interesting bit of advice years ago from my thesis advisor who said, let the known lead you to the unknown. So if you know something, that'll get you to the next place, but you have to start with what you know. And so when you're determined, it's very easy to rest on that as opposed to being worried about, well, I don't know this, I don't have this, all these unknown things. Like, focus on the known. And determination, I think, allows you to kind of, seat yourself in that space really comfortably.
I love that. I think that will be a great mantra because a lot of people in this space have imposter syndrome. Yours truly, other people in the veterinary space, in the science space, and we focus on what we don't know. So maybe just start with what you know, and you know more than you think, and let that lead you. So amazing. Okay, now back to the science. So what are you focusing on as a researcher?
What am I not focusing on?
I
That's the
love
really
that.
cool
He's
thing
like
about
everything.
yeah, that's the really cool thing about having your own laboratory. Like the boundaries kind of get progressively bigger because you know more and then you know about what you don't know. And then you say, hey, well, maybe I can ask this question. So our lab right now is really interested in the idea that fat, lipids affect how our bodies respond to disease, particularly cancer, but we also study infectious disease as well. That's where I actually did my graduate work in. It was in HIV, HIV replication in particular. So we found some really interesting things in this space, and we just realized that there's so much that's not known, even though we have all these advances in treatment, all these different types of therapies that exist now. But there's this big gap where we have no idea where a major part of our biology, this big class of macromolecules, fats, where we don't know how they're really interacting with all these other things that we have going on.
Wow. So I guess if for our listeners who are like, I don't know, fat is fat, like maybe we don't want it. And like for veterinarians, like we have a lot of obese pets, but like why? Like it's linked to inflammation, I think I saw on your website.
Yeah,
She stalked only a little.
there's a whole bunch of different ways to look at fat. So fat isn't one thing. Fat is a whole. It's like imagine having like this massive family reunion, and your family exists across every continent. So you have all these differences, all these unique characteristics, and those characteristics dictate how it behaves. So if we just say fat has saturated forms and it has unsaturated forms, let's just group them like that. Typically, saturated fats are the ones that are responsible for a lot of the inflammation that we talk about. But then you have this class of unsaturated fats that typically do the opposite. They're anti-inflammatory. And depending on the state of a person, like the metabolic state of an individual, a patient, for instance, the amount of fat that they have, this unsaturated versus saturated, can largely dictate how a disease will manifest and how they will respond to treatment. And that's what we're really interested in.
Wow. Wow. So you're telling me diseases are even harder to treat because each person might respond differently because the amount of fat that is in. So we have genetic factors, including fat deposition. Okay. My brain is exploding from this because because again, that makes disease just so hard to treat. Wow. That's incredible. And so now you're studying this role that fats or lipids play in cancer. And so, is there any other dynamic we should understand about this? Like, is it how the fats, is it just like the fats interacting with organs? Are they interacting with just like cells, inflammatory cells? Like when we have disease, is it everything? Tell me it's everything.
It's everything. That's it's good
Dr.
for
Simmons.
me, right? It's good for me because that's like what you call job security. But the reality is that the interaction happens on multiple levels, and depending on which part you're focused on, you may see different things. So, like for your average person who is dealing with a patient, like a clinician, they're looking at it at a much higher level. Whereas for someone like me, a cell biologist, I'm trying to understand, well, this particular cell, what is happening when that fat is in its environment, when it's in its neighborhood, so to speak. And so, depending on the question you ask, you may see something very different. And so, what we're really hoping to do is start to have more dialogue with clinicians to ask, well, your patient's presenting like this, but if we were to do like a lipid profile, like high level, highly detailed level of understanding of the specific types of fat, we might be able to say in our laboratory, well, that's actually going to create this situation where their immune system isn't going to do what you think it's going to do, or eventually it's going to stop doing that, and we're going to have to do something different. And that's where the rubber really meets the road in terms of that determination because like, oh, this is getting complicated. Do we really want to do this? And I mean, the answer is yes. We really want to
Yeah,
do this.
yeah, it's
Yeah,
really well done. So that's really interesting because I think sometimes when people think about research and then people think about clinicians like me, they think that the two are very, very separate roads. But you literally just gave us an example of how the work you do can help impact what people are seeing on a higher level with patients and how what they're seeing on a higher level with patients can influence you on a cellular level and what you do in the lab.
exactly. Absolutely. One of the projects we have right now, we're fully engulfed in this, like looking at electronic medical records and trying to understand, well, that patient responded this way, but here we have some of their metabolic profile data that indicates that their response to the treatment was actually influenced by this profile, even though everything that we have come to know based on clinical trials would suggest they should have responded a different way.
Wow. That's really, really incredible. Have you had to pivot your research because of what you found out? Just curious. Have you been like, no, I think it's going to be this? Because that's a recurring theme here with researchers. And I think sometimes students are like, you know your theory, you know your hypothesis, you prove it, and you're done.
Yeah, no, I mean, I think the one thing that you have to be, I think, as a researcher, is humble. You're going to be wrong more often than you're right, and that's okay because I don't think you learn from being right. You learn from being wrong. And so I've pivoted plenty of times. As a matter of fact, the project that I'm describing right now, I had a whole hypothesis laid out. It was going to be beautiful. It was like this is going to happen here, 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 and here, and then you start looking at the patient data, you start looking at your experimental data. And it was actually one of my undergraduate students that showed me this result. They look completely backwards. And that set everything, on the path that we're currently on.
Yeah. That's so neat. And I think sometimes people forget that negative results are results. They're helpful. Like, even though they don't support what you're saying. Okay. I read that you use 3D bioprinting technology. Okay. To develop, she looks at camera, shaking her head, not knowing, to develop novel patient derived in vitro tumor models for testing therapies for lung cancer. Okay. That does sound super high tech. And so for someone listening that's like, what? Can you explain all of that?
Yes, absolutely. Again,
Okay.
word soup. But the
Yes.
the big thing when it comes to doing experiments such as the ones that I carry out in the laboratory is that we're very far removed from patients. We're not treating patients because some of the things that we do in the laboratory you can't do to a person. It would be far too dangerous. But one of the things that we know is that animal models are actually a really good way of testing some of these things, but there are limitations. There's a lot of constraints in dealing with animals. And so, what we've decided to do is take advantage of bioprinting, which is basically taking a machine that can physically print material. And we're printing living material. So, we're printing cells within a gelatin like substance. So, the cells are inside of it, and we can basically create a structure that could mimic the shape and the size of a particular organ. We can actually create artificial structures where we can kind of separate different cell populations from each other and make them or allow them the opportunity to move towards each other in order to see their responses. The big thing here, though, is that we take patient samples and put them into these constructs, these structures that we're creating in the lab, and we can take a single tumor and we can basically clone it. We can replicate that tumor across multiple structures. So that's like having one patient and then saying, okay, now we're going to multiply you, and then we're going to test this treatment, this treatment, this treatment, and this treatment, and whichever one works best, that's the one that we're going to try to see if we can get it back to the clinic so that we can actually help the actual patient.
Oh my goodness. So, okay, I have two questions about that. So what is that timeline? So you get their cells and you're helping them in real time, it sounds like.
Well, that's the plan. We haven't started doing it yet, but the idea is that we know that when you're using animal models, that can be on the order of months to years before it gets back to the clinic. But if we're able to take something directly from the patient, put it into a system that we could actually cultivate for a matter of weeks, we could shorten that timeline, but we also bring down the cost because we know one of the major issues with the best medical care is that it has the highest cost. And what we're looking at is essentially potentially a version of personalized medicine where we could take a patient tumor, treat that tumor, and then say this is the treatment that would work because we've tried it across 1,000, bioprinted tumors for that patient, and it only cost us a few $100.
And so now you're telling me better cost and then patient-specific care, which means they might not go through treatments that have terrible side effects that won't even work.
Right, right. Because ultimately efficacy is the thing that we're really aiming for here. So combining, some of the stuff we were talking about earlier about looking at patient level patient-centered metabolomics or metabolism studies, along with these 3D bioprinted constructs, these structures that we're mentioning, we have a patient avatar with a deeper understanding of how metabolism is affecting the immune system ability to eliminate the cancer.
That's incredible. And so I guess my question is, why lung cancer? Is that where you started?
That's technically not where we started. That's where we
Oh,
landed. That's where we landed.
oh,
So our lab is what we call cancer
pivoting.
agnostic. We're always
Yeah.
pivoting.
I
Um,
like that.
yeah, so we're kind of agnostic. We don't really hone in on a single cancer, but we look at cancers that we're able to see some of these mechanisms are playing out in. So cancers like glioblastoma, for instance, is a very different type of cancer where some of the things that we study in lung cancer or even in kidney and prostate cancer, it does not happen the same way. So we're a little lost in that space. But we do study multiple cancers currently, such as sarcomas, breast cancer, lung cancer, and kidney cancer and ovarian cancer.
So wow. So some cancers behave kind of similarly, but then like something like glioblastoma is just like really different because surprise, cancer. Right. Wow. And so that's just incredible. And there are other things. Like I read that one of the things you're most proud of, which there are so many, was the work you did during the pandemic in helping communities measure the prevalence of COVID. So like, wow, we were just talking about cancer and what your lab does, and obviously you do all of these things. So what about that project and how did you get into that?
Yeah. Talk about, doing things out of necessity. Necessity is the mother of invention. So during, the early stages of the pandemic, my lab was actually based in Minnesota at the time. And any lab that was not directly in a space where they could do something related to COVID was shut down. And my lab was a cancer biology lab. So we were shut down. But we were very much so, community oriented. We wanted to know what we could do. And the unfortunate reality of a lot of diseases, and particularly like the pandemic, it disproportionately affected, some populations. And one of the major things that we noticed was that everyone could not be tested at the same rate. It just was not going to happen because there were limitations to how the testing was being implemented. A lot of places were drive-through. So imagine if you have a population of folks who can't drive, but they're located so far away from where the testing centers are, they're not getting tested at all. And that's not even going into where there was actually issues where folks were being turned away. That's a whole nother conversation. So we decided to figure out if there was a way for us to measure the prevalence of COVID in different areas so that we could better help the different, municipalities to redirect their resources. Because what was happening in Minnesota at the time, and I'm sure a lot of other places, was that some hospitals would get completely slammed. They wouldn't have enough resources for the number of cases that were coming in, but there were enough resources somewhere else. But it took time for those things to move. And so we implemented a system that basically surveyed the entire state of Minnesota. I think we started with about 19 cities and we got up to 44. So we had somewhere close to like 80% coverage for the state based on the population, where we could help the actual state government, see what was happening and predict what was going to happen in like a 2-week window. So they had ample time to make adjustments. And I think the program is still running to this day. We were able to hand it over to the state health department so that they could implement it into a bigger program that actually took in some additional technology that we weren't able to implement when I was running it.
That's incredible. So instead of a hospital just having like all the materials or whatever resources they need and just being like, oh, we don't have enough, like we have people coming in, but we still have excess supplies, and other hospitals, like a feast or famine situation, you took that situation and we turned it into one where we could like equally provide where the need was the greatest. That's amazing. But I read something, okay, again, I may have read it quickly, but something about wastewater in Minnesota?
Yeah, so that was the whole system. The system was based off of collecting wastewater samples from the individual cities because that was so the biology of, oh, there goes my light. Gotta love this energy efficiency. Sorry about that. But one of the big things that was known at the time is that the viral particles can be shed from a person long before they show symptoms. And so we decided that if we were able to determine where we could see that in the wastewater, we would know that there are people who are infected who may not have shown up to get tested yet or shown up to a hospital because they're feeling sick. So that gives you that predictive value right there because, again, you don't tend to go to the hospital unless you're sick. Everybody doesn't get tested, just for any old reason. So seeing it in the wastewater is a good indicator that something is going to happen, especially if it's a significant spike.
This is why I think science is so freaking cool. Sorry, Cornell, I said freaking. It's really like that's amazing. And then because you were seeing it in the wastewater and they probably wouldn't show severe signs for a little while, you actually even had a little bit of time, like to try to get that little bit, right? To get resources there. That's just brilliant. Oh my gosh. And to see like your efforts now still being used, that's incredible.
Yeah, we usually
Wait,
have
and
have a
yeah.
delay in, that level of satisfaction. You publish a paper, it might get cited, might not. So to see something like that was probably like, wow, okay. And everyone's like, oh, you should do this all the time. This is what I do, but I'm a biologist, so I can do this. But I'm going to leave that to the professionals who do that all the time.
Way to use the things you do for such good. Like that's just really amazing. Oh my gosh. Okay. I know I deviated, but okay. We in the beginning of my whole description of you and your amazing bio and on your lab page, you have said that your lab works actively to eliminate health disparities. And I'm going to just review for people who may not understand kind of the seriousness of this, right? Like health disparities are literally preventable factors, right? Like and differences that will disproportionately affect certain people like in certain groups, right? And why why is that important to you? And what are you doing in this area to make change?
So why is it important? I think it's completely ridiculous to think that anyone in a place as resource rich as we are in the United States should not be afforded the access to the technology, the services that we have here. That's the why, right? The second part, what I'm trying to do, and unfortunately or fortunately, it's like I wish I could do more. Like I am a biologist, so there's so much that's involved in understanding, what a health disparity is, where it comes from, how to potentially mitigate it. Where as a biologist, I'm coming into it late, where like I don't know, but let's see if there's a genetic factor. Wait, there's no genetic factor. So what is the issue? And so I've really gotten involved in a lot of education outreach efforts. So a lot of the publications that I have in that space, typically I'm the person involved in educating. I'm going out to the community, I'm having conversations because one of the major, things that has been cited as contributing to some of these health disparities has been not just access, but like a fluid communication between the medical community and the scientific community and those who need to use those services. And so by utilizing myself, I'm going out and I'm trying to have these conversations. And the pandemic was, in many ways was just like almost a culmination of all those experiences I had before, because I'm going out and we're having difficult conversations about immunology. We're having difficult conversations around conspiracy theories. Some folks don't want to have those conversations. I didn't want to have those conversations, but I was willing to engage so that we could find a middle ground so that we can, get through this crisis. Not so much to debate, but to find like, okay, well, where's the truth for you? And here's the truth regarding, as far as science is concerned, let's figure out that middle ground so we can move forward successfully.
Yeah, I appreciate that. And I hope people that are listening are keeping an open mind because I know that there are some that are like, well, this is the US. Everybody has the same access. Again, if they can afford it, we won't get too much into that kind of disparity. But even if they can afford it, there is proof. There is research that shows different groups get different care. That is just the bottom line. And so you're doing your best to try to educate in that space. And, my hope is that there are plenty of researchers like you that can eliminate it one day. I say that very, very hopefully, right? because these can be life or death situations. And I think I want to make sure people understand that this is not just like you didn't get an appointment on time, right? And so really big deal. Wow, that's really incredible. And I think that education part is going to take me back because it is not easy to educate in that space, right? So when you said that you have to debate sometimes, I understand that. And someone who tries to talk on access to care, veterinary care for everyone, including people who don't have a lot of financial resources, it's very important to me that people across the socioeconomic spectrum can get the care they need for their pets because they love their animals too. Right. And so this really ties in. And so it also ties into, representation and you're there and you're trying to be this example for others who may want to work in this space. Everybody deserves a chance to work in this space. And so I'm sure you have acted as a mentor. I'm sure you're a mentor to the people that work in your lab. And I read that mentorship has played a big role in your life. You even mentioned it when you were talking about your thesis project. So how have your mentors helped you? One, how have they helped you? And two, what are you doing with that? Talk to us. Tell everybody what you're doing.
Okay. There's so much.
Just
so much.
that, just so little.
Just a little bit. My mentors literally, there's a concept of mentor and sponsor. And for me, it was very difficult to distinguish those roles because some of my mentors were the best sponsors in the sense that they were the reason why things were happening and I had no clue. So to me, a sponsor is someone who kind of basically says, okay, I'm going to put your name in this hat. I don't, whatever. No skin in the game. I'm just putting your name in the hat. I had people who would do that and then turn around and then make sure that I was eating, right? Like that level of, hey, I'm paying attention to you as a whole person. And for me, my mentors definitely opened doors, opened my mind to the possibility. While I was at Moffitt, it was like, oh, research is fun. I have no idea what I'm going to do with this. I had a biology degree. If you have an undergraduate biology degree, it's not a lot you can do with it. And from a practicality standpoint, it's like, okay, you have to figure out what you're going to do. It's not like having, an accounting degree. It's like, yeah, I don't know what I can do. I can pipette. And so they were the ones that pushed me, said, hey, it's possible. Graduate school, don't worry. Like, yeah, you're an average student, but you get to grad school, you're going to not be average or you're not going to make it. That's it. And what I took from that was the reality of seeing individuals that I knew on paper were stronger students than myself. And then I realized, but we're in the same place now. Look, we're here together. You don't have any idea that I'm freaking out in my head right now. And the only reason I'm here is because someone told me I needed to be here. And now I'm here. And now I'm here, at Cornell with my own lab and still freaking out in my head.
Yeah. I mean, literally, your lab has your name on it. Like it's your lab.
Yeah, exactly.
Yeah, that's pretty amazing.
Exactly.
Amazing. Yeah.
So now as a mentor, I kind of try to allow for that level of you're here, you're welcome. I'm still going to hold you to a standard, but whatever you show up with, we can work with it. There is no one way to do this thing other than to have determination. Whatever that looks like, you have to be determined. And, the idea of seeing not just, because I don't want to say DEI for the sake of saying DEI, but to have people who are so different in one space, but unified around a single idea is probably the most beautiful thing that I've experienced in being a scientist. Going to international meetings and everybody's kind of just hanging out. And I'm like, I would have never thought that this would be something I would be a part of when I was growing up in the neighborhoods I grew up in. It's like very homogenous, not a lot of prospects, but to be in a space now where due to the mentorship I received, now I'm mentoring students that look nothing like me, that don't have any clue of the experiences that I've gone through. And that's okay. But now it's like, okay, but I can come in with that experience and say, I can offer grace from a different kind of, position because, hey, it's hard for everybody for different reasons, but here we are together now. Let's do something awesome with it.
Oh man, I love that on so many levels. I think sometimes people forget homogeny in this space may not actually work to your advantage. Diversity of people means diversity of thought, means diversity of input, and that could change everything you do in a lab, even though one might not think of it that way. I love that. And then the other thing I just want to highlight to people listening is that he said that there could be average students, there could be great students, and yet they could end up in the same place. And I tell this story a lot. I may not have been the greatest test taker in school, but that doesn't mean we're not great doctors, we're not great scientists in this space where we're not bringing what we can bring and making science better.
Absolutely. Absolutely.
And so I love that so much. Yes. Okay. I wrote a little, okay. So there are two things I need to make sure I mention. So there are some fun pictures on your lab website. And again, I'm here for it. It was like fun during the winter. And then one was labeled like pictures of 2024 and there was cake. So I would like to know, do you recall what cake it was? Was there more than one cake? Because I'm here for cake.
There actually, yes, because we tend to do cake for every birthday.
I'm sorry.
Cake for every birthday. So yeah.
Incredible.
Yeah.
Okay. Do you have a favorite cake?
I'm actually more of a pie guy. I'm a pie guy. And everybody knows that. Everybody knows that.
I think this interview is now over. I don't know what to do with you. Okay. If you had to pick a pie, because holiday season's coming up, so pie's going to be big. We have Apple Harvest Festival here, so you'll be doing the apple thing. I like how the lights just came on for that.
Because idea.
We woke up the lights.
There you go. So
okay, what's your pie of choice?
I'm a big peach cobbler guy.
Ooh,
peach cobbler.
Oh, solid.
But also, because when I relocated here, my favorite grocery store in the whole world happens to be here, and they have an amazing key lime pie.
I like key lime pie.
Key lime cheesecake.
Oh man, I'll eat any. I'm like dessert is dessert. It's actually why I work out. I literally work out so I can have cake and pie. Yeah, that's 100%.
I endorse that.
Yes, you heard it. You heard it, everyone. I saw that, actually, I saw a link that I thought was really unique. Over the last few years, I've been doing some talks and just kind of telling my story because I'm a first-generation American. And again, science is a pretty new space for me, even though my siblings went into science as well. I saw that you have done a lot of spoken word events. Like you tell your story too. So can you just share with us how you got into it or why you do what you like about it? Share anything about it. Talk to me. Story, spoken word events.
So spoken word. So I got into spoken word kinda because I wanted to be cool, right? Honestly,
Yes.
because
Yes.
I saw, I was a young guy and, it's like, hey, you need a way to get yourself out there. But I hung out with writers. I was always impressed with their ability to articulate complex ideas in ways that just kind of say, it makes you think a little bit deeper. And so I started, writing very badly in college. And then I got into grad school and I kept doing it and I kept hanging out with more amazing artists that are very interesting people. Artists and scientists are not too dissimilar. And the person that told me that was Maya Angelou in a big meeting that I went to.
I'm sorry.
Yeah. She said we're artists. She said scientists are artists, and I said yes. I'm going to take that with me. And I couldn't help but feel like I need to communicate better. I felt like I always had a lot going on that I couldn't articulate, and so I began learning how to write. And you start by writing by imitating some of your favorites, and then my own voice started to develop. And then subsequently, I started doing slams and I started coaching. And now it's kind of like in my back pocket whenever I'm just kind of like, hey, let's go, do a little bit of writing. So I think it's such a useful way of communicating. Writing is nice, but being able to communicate vocally, I think it's so much easier for people to receive. Even though the pen is always going to be the thing that lasts for forever, but there's nothing like being able to hear someone articulate something in a way that resonates with you. And I think that's one of the reasons why I really like lectures. Lectures are so much fun when I'm like, oh, I know this is my topic, or I'm giving a seminar. It's like, yeah, let's go. But yeah, it's just, it basically ties everything together. And I think the creative process is inherently a part of science. So it just makes sense for me to do it.
That is really fantastic to hear. And I think you actually articulated what I wanted you to say. Like, you're communicating with a bunch of different people. You're using it in your lectures. Like, that excitement gets passed on then to the students. And I hope they take that away from you because they know you're passionate about it. But more important, let's just get rid of that. You knew Maya Angelou, and now by knowing you and 6 Degrees, I now
There you
knew
go.
her.
There you
Yes.
go.
And so that's pretty amazing. That's incredible. Next time we lead with celebrities here on this show. So like if you come back, you can lead with food and celebrities.
There we go.
Favorite podcast, since you like the spoken word, I'm just curious. You have have you listened to Story Collider or The Moth? Shout out.
I have listened to The Moth.
Yeah.
Let me see. Oh, some of them I probably can't say. 'Cause
What is he listening to?
It's like bad candy, right? It's like you shouldn't talk about that. Well, here's the thing. I really like the Immune podcast. Yeah, which it's always weird because the idea of meeting celebrities, like so coming to Cornell, and it's like, oh my God, it's you. So that was really cool. Getting to meet Cindy and everyone like in real life, and like
That's cool.
like I get to talk to her on a regular basis now. Let's see what other podcasts. I'm actually a big productivity podcast person, which is weird. It's a weird thing, and then eventually get tired of. Well, because it's like you're not being productive while you're listening to it. It's like you're too busy.
Your brain is doing its thing. Yeah,
I don't know. It's like the podcast version of scrolling, right? It's like you're scrolling. Are you actually doing it now? So like Beyond the To-Do List was one of my favorite ones for years. I like listening to parenting podcasts just a little bit because like sometimes I get some cool ideas. So yeah.
That's really neat. There are a couple, like as somebody who's interested in biology and immunology, there are quite a few that talk about really neat things as far as disease and like how people handle them. I'm like, it's really, I'm not that productive, kids. I'm clearly listening to too many podcasts, and true crime is where I'm at. So before I let you go, because I know you have lots of important things to do, I wanted to just briefly, I like to do a little lightning round. We already covered pie, and that's okay. We're just like a couple of questions to get to know you. Do you have a favorite restaurant in Ithaca?
Mix. Mix is probably my favorite.
Oh,
it's just
nice.
It's such a random cavalcade of things. Like I never know what I'm gonna get. So yeah.
Have you been to a Sempe Kitchen? Shout out to a Sempe Kitchen.
I was there while they were putting it together.
Oh my gosh. Delicious, vegan friendly if everybody wants it. Okay, we have what about favorite activity when you are not in the lab? What are you doing?
Wandering in the woods.
Wandering in the woods. I forget that people do that like intentionally.
Yeah, I'm all about that.
Okay. Are you a sports fan?
I am, but not any sports I can see locally.
That's what I was okay.
I'm a rugby fan.
You're a rugby fan?
I'm a former rugby player, so yeah.
What? Okay, everyone. I know we don't like rugby is not as big here, but like 15s or 7s?
I played both. 7s hurts.
Yeah.
It hurts. The cardio is too much. It's too much.
That's valid. That's really, really valid. Okay, favorite rugby team, if you want to share that with the world.
All Blacks.
The All Blacks. Come on.
Come on.
They're amazing.
Come on.
They're amazing. Okay. Well, I'm trying to, salty or sweet? I've got to ask this one.
Sweet.
Yes. Okay, we're good. This is great. Thank you, Cornell, for bringing in brilliant scientists that also really appreciate just straight sugar. Thank you so much for joining me.
No problem.
It has been so great getting to know you and getting to know all the incredible things that your lab does and the incredible things that you do for our student population. If there's I'm just going to ask you one more thing. If you could just impart, if there's someone out there who is a young person and they're thinking about science, but they think they can't do it, what would you tell them? Is there anything you want to tell them right now? They're listening. Okay. They're here. You've got the mic.
Oh man. It's like, I want to have something like really clever to say. Yeah. Don't let fear stop you from doing anything. Another way of, I would say that is that you should always be running towards something, not away from something.
Yeah.
Yeah.
I love that. Unless you're being chased, in which case that's the only time I run.
You know, that's different.
It's the only time I run.
Yeah, that's
there is no running.
But again,
otherwise.
that's an actual threat. You know,
right?
That's an actual threat.
True threat versus. So I really appreciate that, because I'm sure that there are a lot of students that are they're scared because maybe they didn't do well in a certain space, or they think they can't. But that certainly shouldn't get in their way. They should at least just keep trying. Yeah. Determination is a superpower. You heard it here.
There you go.
With Dr. Simmons. Thank you again for joining me. And thank you everyone for joining me for this episode of the Cornell Veterinary Podcast. Go to your favorite platform and subscribe and rate 5 stars, please. And we will talk to you all soon. Thanks for joining us.
Thanks for having me.